Okay, well, welcome everybody. This is this month's installment of the HADR virtual chapter for PASS, September 2016. So for meeting logistics, we do not have a dial-in bridge. Audio is just off of GoToWebinar here. If you're on Twitter, feel free, comment, tweet about this, use the HADRVC hashtag. Audio will be disabled, but I would love for you to ask any questions you want. Please put them in the questions window inside GoToMeeting. And we have a couple of breakpoints in the session today, and I'll be sure to relay those. We'll make sure they get answered. It is being recorded, so if you're not able to attend today, well, one, you wouldn't be on here right now, but it'll be recorded, and we're going to have it up on our YouTube site right here pretty soon. Make sure to check these out. We get these posted pretty quickly, and there's a lot of really good information from past sessions on there. For technical assistance, there is a maximize button at the bottom there if you need to zoom in on any of the demos or things. Also, please type in your question on the right side of the question pane. Normally, we meet every month on the second Tuesday at 1 p.m. Eastern. So again, please put that on the calendar and check it out. So today we've got Steve Stedman with the Database Corruption Challenge. Next month we have the SQL Server Tiger team talking about common troubleshooting scenarios with availability groups. So make sure to check that one out next month as well. If you're not signed up for the PASS Summit, please talk to your employer, see if you can get them to pay to go. Use our promo code here. This really is the #1 conference for SQL Server professionals worldwide. It is phenomenal. I'll be there. I know a bunch of people are going to be there, and it is just great. So we just missed the deadline for the last call for the Passion Award nominations. Hopefully you nominated folks that you know that are really involved and dedicated to the community. If you missed the cutoff, go ahead and submit them anyway and get them in there for the next round. We do have a number of other virtual chapter meetings that are meeting this and next month. A lot of really good ones on here, and I wish I had a lot more time to watch these live. I tend to watch a lot of these recorded. Some really good ones here. If you're not active with a lot of the virtual chapters, I urge you, these are some of the best sources of current, up-to-date, world-class information. They're free, they're every month, they're recorded. Sign up for the notifications on a lot of these out at SQLpass.org. They're really, really good. If you're not in an area where you've seen a lot of SQL Saturdays, go revisit. These things are popping up everywhere. The SQL Saturdays are awesome. I'm going to be at the Dallas and the Minnesota one here pretty soon. That's just US. There's a lot going on all over the place. So check SQLSaturday.com. There's sure to be one near you soon. You got to go. They're wonderful. And if you have some time, I urge, go to volunteer.sqlpass.org. The PASS organization needs all the assistance that we can get with stuff like what we're doing today, different conferences and SQL Saturdays coming up. So check it out, get involved. It's a great way to get to know a lot of the folks in the community. And sign up today. Free membership out at sqlpass.org. They're out at LinkedIn, Facebook, Twitter, and out at their primary website there. So today we've got Steve Stedman, a freelance SQL Server consultant. You can read his blog out at stevestedman.com and out on Twitter at SQLEMT, which I think is a really cool twist. He's got 25 years of advanced database and SQL Server experience, and we welcome him. So I'm going to turn that over to you, Steve.
Thanks, David. All right, let me show my screen and we'll get started. So the presentation today is on when database corruption strikes. And this is one of those things that has come from my experience working with database corruption over the last few years, as well as working with the Database Corruption Challenge in 2015 and getting ready for a presentation at PASS Summit this year on database corruption. A little bit about me. My background, I am currently the weekly podcast co-host on the SQL Data Partners podcast, and that's at sqldatapartners.com/podcast. I blog regularly, as David mentioned, at my stevestedman.com site. Created the Database Corruption Challenge last year, and we're working on another Database Corruption Challenge in the future. I've built the Database Health Monitor application over the last few years, and that's something that's a free download. and I guess 26 years of SQL Server and database experience. And I'm currently working with Stedman Solutions, a company that I started, as well as SQL Data Partners. And I'm the chapter leader of the Bellingham, Washington SQL Server Users Group. So things we're going to take a look at today will be some of the common causes of corruption. We'll take a look at what we can do to detect corruption and how to deal with it, and then tracking it once you've actually detected that you have corruption, and then things you should do before you jump in and try and fix it. There's a lot of things that if you just jump in, you might cause more trouble than slowing down and taking a few steps ahead of time. And then we'll look at what we can do to remove corruption, and then go through some examples showing things we can do to actually update and get rid of corruption along the way. So the database corruption challenge, this was something that I ran last year. It ran, I'd say, for about 10 weeks. It was more, it was 10 events over about a 15-week period. And what I would do is create a corrupt database and confirm that it could be completely recovered somehow. And then I would post that corrupt database and let participants send me their solutions. And all of those databases, the corrupt databases, are available for people to take a look at, as well as solutions on how to solve it. And most of them have multiple ways of fixing the corruption at stevestedman.com/corruption. Now, one of the side effects that came out of that, somehow the judging of the database corruption contest and the word corruption and judging somehow got me search engine optimized for people who are looking for corruption with judges in the legal system. And just to clarify here, this is database corruption, not legal system corruption. I know I get a phone call about once a month from someone needing help with a corrupt judge, and I don't help with that. So I look at training for database corruption. It's like training for CPR. It's one of those things that you want to practice, you want to plan for it ahead of time, because with either of them, when you need it, it's too late to learn. And if you don't know what you're doing when you need to use either of these, outcomes can be very bad. And regular practice is really needed to keep your skills up to date and sharp with this, with either of them. So some of the causes of database corruption that we run into are things like drive storage or failure. Commonly, a drive will fail in a RAID array, and someone will go and replace that drive, and things don't always rebuild 100% correct, especially with some older drive arrays out there. And one of the things I've run into is that the day after a drive is replaced in a RAID array, a corrupt database shows up, and you have to go fix that. Power outages, well, database pages are being written to. I've had a couple clients I've worked with where they said everything was working great with my SQL Server. We had a power outage. Of course, this was with a SQL Server running in their office rather than in a data center. Had a power outage, and when it came back on, the database didn't work anymore due to corruption. And those can be mitigated with battery backups or putting your SQL Server in a data center, but it's one of those things that happens if you're running a SQL Server in an office. And then oftentimes if you have network issues with network attached storage, you can have problems. And really what it all comes down to is that most of the time SQL Server corruption is caused by problems with I/O. So, confusion with database corruption. There's a lot of things, as I'm working with different database corruption scenarios and different people out there, there's a lot of things that come up where people say, well, backup and restore of a corrupt database may help fix the corruption. Well, the fact behind that is that's completely false. When you back up your database, it's backing up things one page at a time until the entire database gets written out. And the way it's backed up, if a page in your data file is corrupt, then the backup is going to be corrupt also. And if you restore that backup, you end up with a corrupt database. Another one that's a confusing point that comes up is people say, well, maybe if I just reboot my SQL Server, that might help with corruption. Rebooting seems to help a lot of things, but it doesn't help with corruption. Once your file has become corrupt, you reboot, you restart the SQL Server, and the entire database just gets reloaded with the same corruption that was there previously. And this is one of the worst here, is if I just ignore the corruption, maybe it will go away or fix itself. Okay, that's really unlikely. Now, if you happen to have a regular process that truncates a table, and that's the table that had corruption in it, yeah, then it might go away. Otherwise, And I know that's not common with most databases, but otherwise it's extremely unlikely. In fact, it's more likely that if you just ignore it, it's going to get worse. If you have corruption in your database, it's likely that over time you'll either have more problems or it'll grow into more pages in the database. Keep it in mind that oftentimes when you have corruption, it's caused by something to do with I/O, and if you don't deal with the problem with whatever's causing that I/O, you're likely going to have more corruption there as well. So basically, corruption is when you end up with data pages or some part of your SQL Server that SQL Server tries to read the page and it's not formatted in a way that it's expecting, or it has garbage written over where it's expecting a page header or column information or something like that, and it just can't use that page. So one of the ways you can find that is with the dbcc CheckDB command. And what that does is it goes out and it scans your entire database, and when it runs into errors, you get a nice red output here, if you're running it through SQL Server Management Studio, that tells you where the errors are. Also, when you run CheckDB, it will write to your SQL Server logs so that you can go and find it there if you have it running as a scheduled task. The other thing you can do is you can run, a lot of people might say, well, my database is too big to run CheckDB regularly. So one of the things you can do is run checktable on your tables inside of the database. And checktable is not as comprehensive as CheckDB, but what it'll do is it'll do the same thing that CheckDB would have done, but just for a single table. So in this case, it's checking a table called revenue, and it's encountered corruption in a specific location, as shown by the red errors there. There's also different dbcc checks on check constraints, check catalog, check alloc, check file group, and check ident that will go through and check different parts of your database for corruption as well. But when you run CheckDB, that hits all of those. One of the things that over time that you can check as well to see if you've had corruption encountered is the MSDB suspect pages table. Now, you want to be careful with suspect pages because you might see this and think, well, if I ever have database corruption, it's going to show up here. Well, that's not the case. If you run CheckDB or checktable or any of those things, they show your corruption in the error log or in the output, and they don't write that to the suspect pages. It's only when a database is being restored, at least that's the cases I've seen where it's being restored and corruption is encountered, that things get written to the suspect pages table. Another way that you might find corruption is just by running a query. Here's an example, select star from revenue, and it comes across a big red error message. It says SQL Server detected a logical consistency-based I/O error. See, back to I/O there. It commonly comes back to I/O, and it's trying to read a specific page on a specific database and to check the error log. And you can find much more information about it in the error log. But that's the kind of thing that when users are connected and running queries or through an application, that they may see this type of message showing up in their application, and as a DBA come to you and say, what's wrong with the database? Another way that corruption might show up is after you've restarted your SQL Server, especially after a power outage or something, it may come up with the recovery pending message, where it shows that the database has attempted to start up, something failed along the way, and it leaves it in a recovery pending mode. With that, you generally have to deal with fixing the corruption before you can get that database to come online. So, tracking the corruption. You want to look for error messages in the error log and to be able to dig into deeper detail to find out exactly what's going on. So for instance here, from this error log that we're showing on the screen, or this error message, not error log, this error message, we can see that it's giving us the object ID of what table that the corruption is in. It has the index ID. An index of 1 would be the clustered index on that. And it's even giving us the page where the corruption is and the row in that page and what the problems are. So you can learn a lot from the error messages, as long as you know how to follow it and how to track it down, and we'll take a look at that in a minute. You can also look at the the SQL Server error log, where you're going to get errors showing up where you might not necessarily have the red highlighting like you see on the previous message, but you're going to get details on exactly what's going on here. For instance, in this case, there's an I/O error with incorrect page ID on page 9 in file 1, where it says it's actually showing zeros on it, which means that there is likely a corrupt page or corruption on page 9, which is the boot page of the database, which will keep that database from loading. Also, taking a look at the error log, you'll see messages when CheckDB runs that show up that give you additional details, and will even give you a dump file that you can go look at with additional details that show what was happening when that corruption was encountered. So, once you've found the corruption, you've got a little bit of detail on the error messages there, you want to go poke around and see what you can find. See what is working in the database versus what's not working. So for here, the example is select star from revenue, which is a table, and if you get back 54 rows, which was in this case the number of rows that were in that table, I was expecting in that table, then you know it's good. Or do you? You know that you're at least getting a result, but you don't know that the results in that table are necessarily accurate. So you want to look further into it. One of the things you can do to look further into it to see what has gone bad is to track what you have in the non-clustered indexes. And this is a great way to compare what you're seeing selecting from a table versus what you're seeing just pulling from the non-clustered indexes. Sometimes you might look at the table and find that you're not able to get a number of rows back, and then you look at the non-clustered indexes and you're able to get the entire number of rows back. And then you can compare the data between what you're seeing in the non-clustered indexes versus the clustered index or the table itself. That's a handy way to try and rebuild data along the way. Now, not everybody has non-clustered indexes that cover every single column in their table, but if you do, you could recreate the entire table from the non-clustered indexes. If you don't have that, you could recreate parts of that table from the non-clustered indexes and use that to go and figure out where the missing pieces are to fill in the holes. So before you jump in and try and fix anything with corruption, there's a few steps you want to go through. First one is, do you have a way to start over if something goes wrong? Now, a couple times I've worked with corruption on clients or for clients, and they have their one server and it's a big server and there's not enough room to restore a database or try and work on it somewhere else. Well, that's a dangerous place. If you try and work on that, there's no way to do over if you start messing with on their one primary production server. So I always like to be able to take a backup of that database and put it on a test server or some other instance or somewhere that you can work on the corruption without impacting the original server. And that way, if you have a way to start over, you can go back and you can make mistakes and try again without impacting that production system. Also, do you have a backup of the current state? Meaning, right now, you know you might have corruption, but if you might have corruption right now, but that backup will give you a way to get back to the current position if something else gets worse as you're going through working on the process. So if your solution is going to cause data loss, can you save anything before causing that data loss? And that's one of the things we'll take a look at in a minute. But when SQL Server encounters a corrupt data page, a data page can hold many rows, when it attempts to clean up that data page with the repair allow data loss option, all it does is it says this page has corruption, let's just throw it out and we'll move on. And you may be losing more than a few corrupt rows when that process runs. So before you do those type of things, figure out what you can pick out of there and save before that data loss occurs. And then, do you have someone to review your ideas before proceeding? Now, we all know that database corruption is one of those things that can be extremely stressful, and you're probably going to be on the spot when you have to deal with it, where it's really important to your employer to be able to get this going again, or they may lose their entire database, depending on the scenario. So to have someone to talk to have someone to ask or to review your ideas before proceeding can be incredibly valuable, because they can just listen to what you're planning on doing, offer suggestions, and maybe offer alternatives to take a look at there. All right, so back to that whole do-over. whatever you're going to do, if there's a way to get a do-over when you're working through the process, that could be incredibly valuable. Basically, there's some that I've worked on this way, where you have a backup, some way to get back to the beginning, and you go through this entire process of fixing the corruption, and you realize, oh, at the end, there's a couple dozen rows missing. Well, then you have to go back to the beginning, start over, save off those rows that were missing in the end, and then come back and put them on, put them back into the database. So if you know you've got a way to do that do-over, it gives you a little bit more options to work through on how you can get rid of the corruption. So, removing the corruption. Some people I've talked to, they say, oh, well, we don't worry about database corruption because all we have to do when we hit it is just restore from our last backup prior to when the corruption was encountered. And in some environments that may work well, but in other environments that could be a problem. I mean, imagine if this was your bank and they had a corrupt database and it was Friday, which was payday, and the corruption was encountered on Thursday night, and they just rolled back to the backup from Thursday, or sorry, the corruption was encountered on Friday morning, and they rolled back to the backup from Thursday night and lost all the transactions for Friday. That would be completely unacceptable. So what I like to do is look at how can we get back to the point in time without losing any data whatsoever, if that's possible. And so restoring from backup doesn't always help with that. Now, also, it's not always feasible. Sometimes when people run into database corruption, it's the first time that they may have ever had to restore from their backups, and they found out that, well, their backup process wasn't working the way they thought it was. I've worked with people where they said, here's our corrupt database. We thought we had backups running, but we only have one backup from 18 months ago, and we want to be able to save what's in the database today and everything that was in between there. It makes it a little bit more challenging, and just restoring from backup isn't an option in that case. And sometimes in bigger environments, you only have a certain backup retention period, and it might be that you're keeping 6 weeks worth of backups, but nobody noticed that it was 7 weeks ago that the corruption was introduced, and every single one of those backups has the corruption in it. Well, restoring from backup isn't an option with that case either. Okay, so on removing corruption. Now, the easy one is if you've got a non-clustered index that's corrupt. That's a piece of cake. Just drop the non-clustered index, rebuild it, do a DBCC CheckDB, and at that point the corruption is gone. Everything's good at that point. Well, it gets more complicated though if you have it in a table or in a clustered index. Now, one of the ways to remove corruption is to truncate the table. You might say, well, of course, you're going to lose all the data at that point. So, of course you are. So what you want to do before you do truncate table is have a way to get all the contents of that table back. Copy everything that's possible off to another table, truncate the table, corruption's gone, do CheckDB, and then put everything back into the table that you were able to salvage at that point, and then figure out how to put the pieces back that were corrupt. Another way to remove corruption, and this one doesn't work very often, but it's worth trying, is the DBCC checktable with the repair rebuild option. And what this does is it attempts to fix the corruption by rebuilding parts of an index or table without losing any data. And in my experience, that really doesn't work very often, but it's worth trying. Then you've got checktable with the repair allow data loss option. And this is the one that says I'm going to scan this table or the indexes associated with it, and when I come into a data page that's corrupt, we're just going to throw that out and pretend that none of the rows in that page ever existed, and then we'll just move on from there, and then when we're done, it'll report that the corruption is gone. Well, of course it's gone. It just threw things out, but you lost a lot of data along the way. And then the last one is CheckDB, which with the repair allow data loss option, which is similar to checktable, but it does your entire database, and any corrupt pages that it finds, it just throws those out. Now, the repair allow data loss option is okay to use if you have all of the data in the table backed up somewhere else so you can put it back in after that corrupt data has been thrown out. Now, I'm not saying put corrupt data back in, but put the data back in that wasn't corrupt and figure out how to fill in the missing pieces. All right, so let's take a look at an example here. So this is one that came from the Database Corruption Challenge, And the way it works is, and this is very similar to what I've had with clients along the way, where they contact me and say, here's a backup file with a corrupt database. We don't have any other backups of the database that wasn't corrupt. Someone already destroyed those, or it's been corrupt for longer than our backup retention window. And however, there's no non-corrupt version of the database to look at. All you're given is a database backup file. So then when you load that backup file in and you run CheckDB against it, you get a whole bunch of errors showing up here. Things about certain rows, certain pages, and different allocation units. And what I like to do on this is start at the top and then work my way down trying to figure out what each one of the items is. So we'll take a look at that in the example here. But before we jump in and do anything, you need to ask the questions again, what would I do first? And in this case, the first thing I'm going to do is jump in and, well, make sure that I have a backup to get back to. And in this case, that's what I was given, so I can always start over if I need to. So what I do first is jump in and see what I can find, see what's in the table, see where the corruption is, see how bad it is. In some cases, corruption is bad enough you can't get anything out of a table. In other cases, it's bad where it only impacts one row, but the rest of the table is fine. So I'm going to jump in and dig around and see what I can find. If my work makes something worse, how can I undo it? Well, I'll just go back to the backup I was given. And what can I do to determine what is corrupt? Well, I'm going to use DBCC CheckDB. I'll probably drill down on DBCC checktable once I know what table it is, and then I will go explore that table and see, and even look at specific data pages to see what they look like. And then once I've done that, I'll come up with a plan to figure out how to recover missing data caused by the corruption. And that one really depends on what I find in the table, because I don't have any other backups. If I'd had a backup from 2 weeks ago that was not corrupt, I could always go back and pull some of the data out of that and merge it with what's in here. But I don't have that in this case, so I'm going to have to jump in and explore the data to be able to figure that out. All right, so let's jump into the demo here. So what I'm going to do is first I'm going to take a look using restore file list only to see what files are there. And there's 2 files that need to be restored. So from that, I would build the restore database statement with the move option to move the files to somewhere on my local drive rather than on whatever server they came from. And I would restore the database. Once the database has been restored, I'm going to start with DBCC CheckDB to take a look at it and see what I can find to see what's corrupt. Okay, so when I run this, I'm going to throw some carriage returns in here so we can see the entire message. It looks like here's the object ID that's corrupt. Index ID is 1, which in this case is the clustered index. There's allocation units, page, file 1, page 280, and all of the messages look like they're referring to page 280 in that same file. And the last one refers to 281 and 246, talking about pointers going back and forth through the chain there on the index chain. So it looks like we're dealing with one page that's corrupt, and that's 280. Now, I should say all we can see at this point is one page that's corrupt. It's possible that there's many more pages that are corrupt, but because of the corruption here, DBCC CheckDB might have given up and not gone any further. So we're going to go take a look at the revenue table, or actually we're going to go take a look, because we know it's revenue table here and that this is the object ID. So I'm going to grab that object ID, throw it into a query here, and see what I can find out about that. So that is the revenue table. It is a user table, not a built-in table, and it's been around since 2015. It's not a Microsoft table. It's not published with replication. And it looks like it's just a regular old table that's been created. So now that we know that, I'm going to use the checktable command to run just against that single table rather than the whole database. And when we run checktable against that table, we get the exact same set of results that we did when we ran CheckDB. So that tells me that the corruption that CheckDB has been able to report is likely only in that revenue table. Okay, so let's keep exploring here a little bit. But to start with, I want to make sure that I'm going to put the database in single user mode. And what this is going to do is throw everyone else out so that people can't be in trying to change data, insert data, update data, whatever it may be, while I'm trying to fix the corruption. Because if I'm trying to change it and fix it and someone else is changing it at the same time, that could lead to trouble. Okay, so we're in single user mode. At this point, I know that I'm the only one connected to it. Let's take a look at what we see in the table. Select start from revenue. We get 54 rows back here. It's a small table. Normally you'd do a table like this and there'd be a couple million rows in it, but that's okay. So from the perspective of the table, it looks like, yeah, there's a bunch of data there. I'm able to query it. I look at the messages window and there are no errors showing up there. So at least the corruption is not bad enough that it's preventing me from accessing the table. All right, so let's take a look then. If we go back to where we ran the check table, we can see that it's page 280 right here where the corruption was encountered. So let's go take a look at page 280 and see what's there. So we're going to use dbcc trace-on 3604, which allows for output from dbcc page and other commands, and then we're going to go look at page 280. And when I run that, the output I get here shows a few things. Well, it looks, based off the type, it looks like it is a data page. This would be two if it was this would be different numbers depending on whether it was an index or clustered column store, things like that. The slot count down here, that slot count indicates the number of rows that are in this page. So if we were to run dbcc CheckDB or checktable with the repair allow data loss option, it would simply just throw out these 27 rows and say the database was fine. But I want to figure out how do we fix this without losing those 27 rows. So we scroll down here and look at the data and we can say, yeah, there's a bunch of what looks like stuff in here that makes up these 27 pages. And there's nothing that's jumping out at me immediately here that looks like a problem, although there is something corrupt in this page. And then at the very end of the dbcc page output, we can see here are rows 0 through 26, which is the location of the 27 rows that are being reported in that file. Now, everything here generally looks, yeah, pretty much all right to me. So we're gonna move on to other things we can do to try and figure out what's wrong here. All right, so let's take a look now at what indexes and columns do we have available. So what I'm going to do is just copy this two queries here. One I'm going to select from revenue, and the other one I'm going to get a list of all of the indexes and columns that we have. And in the top half, you can see we have ID, department ID, revenue, year, and notes. And under indexes, we are clustered on ID. We have a non-clustered index on year and notes, and another non-clustered index on department ID and revenue. So there's 5 columns in the table, and all 5 of those columns are represented in the, actually I should clarify one thing. In the non-clustered indexes, they also have the clustering key, which is in this case the ID. So between the non-clustered indexes plus what they include of the ID, we're able to go and compare what's in the non-clustered indexes to what's in the table. And this is assuming that the index hasn't been rebuilt since the cluster or since the corruption was introduced. So what I'm going to do is I'm going to use the with index option on my query here, and I'm only going to include columns that are in this index that's called NC, bad name for an index. And I can see there we get back a total of the 54 rows. Now imagine if this was a million rows. You wouldn't just be able to glance at it like this. You have to come up with a way, which we'll do in a minute, to figure out what's actually different. Okay, then let's look at the ID, department ID, and revenue that's coming from another non-clustered index. When we run that, we also get 54 rows. And because those indexes are copies of the data from when the index was created or rows were inserted, those might be not corrupt. Well, we know they're not corrupt because checktable didn't report any corruption in the indexes. So now when I did database corruption, the database corruption challenge with the first week, Brent Ozar jumped in with the solution. So part of this is coming from his solution, and one of the things he suggested was looking at the sum option to sum up all of these department IDs and revenue amounts and compare them between the clustered index or the table itself and the non-clustered indexes. So when we compare the sum of all the departments IDs and the sum of all the revenues, we get here 108 and 108 for the department IDs, and this big number and that big number, which are the same between the sum of the revenues. So, and like Brent says here, he's cheating. There could be differences between rows or null values, certainly, but in this case it's enough to do sort of a quick check to say, yeah, they look like they're probably the same. Now let's take a look at the same thing, looking at the year columns and the length of the notes columns. And if we sum up all the years, it comes out to 108,351, which is the same between the clustered index and the non-clustered index. And then we compare the sum of the length of the notes column, which comes back not matching here, 13,727 versus 13,986. So that tells me that somewhere between the clustered index and the non-clustered index, there is something different on the notes column. Okay, so that's likely the only thing different with the table with what we've checked there. So let's just go take a look and see if we can figure out what's different. So what I'm going to do is join the original revenue table using the non-clustered index, joining back to itself using the clustered index. So it's a self-join on the revenue table based off of using different indexes. And then I'm just going to compare where the notes columns don't match. And if the notes column happens to be null, I'm going to set it to an empty string so that we can use the does not equal option there. So when we run that, we can now see that the notes column from the non-clustered index actually has a value here. And again, this was a test database, and I just filled it out with a bunch of things originally, including a GUID there at the beginning. And in the clustered index, that is null. So that's telling me that there's something not right with row 31 between the notes. Okay, so let's take a look again at what we have in that revenue table. And if this was a million rows, you'd want to filter it down just to row with an ID of 31. But if we look here, the row with the ID of 31 jumps out as a little bit different, as that it's showing null in the notes there. Okay, so if we were able to pull, which we were with this join, we know that this value right here is what should be in that notes column in the clustered index. Can we just update it? So let's give that a try, and I'm going to put this in a transaction and roll it back just to test things. And I'm just going to try setting the notes column equal to test, where the ID equals 31. Oh, a severe error occurred on the current command. The results, if any, should be discarded. Okay, well, there were no results. It's just saying, too bad, we can't update the notes column because of the corruption. Next, let's just see if we can delete that row. Because I'm thinking if we can delete that row and then reinsert it, we might be able to get rid of the corruption in the table that way. Oh, another one, severe error encountered. So basically there is something wrong with that row 31 that we can't do anything to it. We can't update it, we can't delete it. So let's see if we can bring back all of the data that's in the clustered index from the non-clustered indexes. So now I'm going to do a self-join to revenue using both of the non-clustered indexes, and from there I'm going to bring back the columns that are represented in each of the non-clustered indexes and take a look at what we get. So in this case, bringing data back from the non-clustered indexes, I'm able to get my original 54 rows back, and row 31 actually shows some data here. Okay, well, it'd be cool if I could just truncate that table and then insert all this data back into it. But as soon as I truncate it, it's going to clear out the indexes and I'm not going to be able to pull this data any longer. So what I want to do real quick is just check the differences. And I'm going to use the query I just wrote there and the except statement and use that against revenue, select star from revenue, and then I'm going to flip those two around and do it in both directions. So that's going to say give me everything from one result set and compare it to the other. And from here we can see that the only difference that's showing up between all of the rows in those tables is that row ID of 31. So if we could just somehow get rid of that and put things back in, we'd be in good shape. Well, the way we're going to do that is create a table called revenue save. We're going to insert into it. So I'll create the table. I'll insert to it that self-join based off of the non-clustered indexes. 54 rows get inserted. And then I'll go take a look at what's in there. Okay, so there's the 54 rows. Row 31 has been rebuilt from the non-clustered indexes without any corruption in it. And then I'm going to do another comparison just to compare all the columns between revenue save and revenue. And we can see that still the original table, it has null in that notes column in row 31. So how are we going to fix that? Well, we can try with the repair rebuild, but I think I mentioned that that very rarely works. Oops, highlight the wrong thing. Okay, try it with the repair rebuild, and that fails. It says can't do it, and it says repair allowed data loss is the minimum repair level for the errors found. Okay, well that means if we have to repair allowed data loss, we're going to throw away things. So let's see what we lose. I'm going to put it in a transaction so I can roll back if we need to. I'm going to do a check table with repair allowed data loss on revenue. Run that, and it says the error has been repaired. So all of the errors through that table have been repaired. What that translates to is we found page 280 and we threw it out. So let's look at what's in the revenue table. There's only now 27 rows in that revenue table, so half of it is missing. So let's take a look at what's missing using the except statement to join the revenue table, or to compare the revenue table against the revenue save table. There are the 27 rows that are missing, including row 31, which caused the entire page to be thrown out. And those 27 rows match up with the slot count that we saw in the page in the beginning. So what I'm going to do at this point, I was going to roll it back, but I'm okay committing it because I know what's missing now and I know how to put it back. So we'll commit that transaction. I'm going to do a check table on revenue. It comes back clean. And then next, I'm going to do a CheckDB on the entire database to see if it comes back clean. Yep, no errors at that point, so we've got rid of the corruption. And if you stop now, we've got rid of it by throwing out 27 rows, or half the table in this case. So how do we put it back? Well, let's take a look at what's different between those tables. All we have to do is take these other 27 rows that we can see are missing from our save table and put them back in. And the way we're going to do that is first to try by inserting into the revenue table everything from revenue save that's not already in revenue. When we try that, we get an error that says you can't insert an explicit value for an identity. So instead we have to use the identity insert option to be able to insert to the identity field, and then we turn it off again when we're done. We run that, 27 rows get inserted, we select everything out of the original revenue table now, we get 54 rows, and row 31 here looks like what we were expecting it to look like. So the corruption has been removed and fixed at that point. Check for differences between the tables. This should come back with no rows if everything matches. And there it is, everything matches, we're good. And check database. We have no corruption at that point. And then I just want to clean up after what I've done here. So I'm going to drop my revenue save table. Now in reality I might keep that around for a little while just to be safe, but I'm going to drop it. I'm going to set the database back to multi-user mode. One of the first things I'm going to do now that I've dealt with corruption is make a backup because I don't have a non-corrupt backup. So I'm going to back this up. I now have a backup with no corruption in it. I can give that back to the client or whatever we need to do at that point to deliver it, and do a final check, and all of the corruption is gone at that point. The corruption has been fixed in this table by purely pulling from the non-clustered indexes and rebuilding the data deleting the corruption, and putting it all back together. At this point, I'd like to open it up to see if there's any quick questions regarding the first demo there.
Yeah, we've got a few really good questions here. First of all, are these scripts available?
Yes, the scripts are, most of them are available if you go to stevestedman.com/corruption, and this was week 1, so you can go back to the week 1 example. Also, what I will do is zip them up and post them on my blog at stevestedman.com when we're done here today.
Perfect. In a replicated environment, will a corrupted database get replicated to another good database on another machine?
Generally, no, and the reason is because replication runs off of the log reader agent, and when what's going to the log generally is regular transactions where the corruption doesn't occur there. And so one option in a replicated environment would be to go and pull the data off of the other server. Now there are cases, depending on what's happened, where there could be data loss that causes someone to do an update or a change that then gets pushed over the replicated server. But usually the other server will not have the corruption on it.
Okay, and then another question. Is it okay to run DBCC CheckDB on a production database? And I answered yes, but I'd like more details from you.
Okay, not only is it okay, but it's a really good idea. However, and I recommend that everyone run DBCC CheckDB on every production database, including the system databases and TempDB, on a regular basis. Now, that regular basis may vary depending on the size of your databases and how much how big of a maintenance window you have. I recommend not doing it during high production times. Although it doesn't cause any locking or blocking, it does add a lot of additional I/O, and it can chew up some memory while it's running. So I would recommend running it as often as you can, because that's the best way that you know that your system either has or does not have corruption. Now, there are other options if you're running in, if you have a system where you're running your backups and doing your restores somewhere regularly, you can run CheckDB there. Not as good as running on production. Or if you're running with an availability group, you can also run CheckDB on some of the other availability groups, although that's not, or the other servers in the availability group, and that's not as good as running on your primary. So I always recommend run it on your primary production database if you can, because that's really what matters.
Excellent. One last question. Can you identify corruption on an indexed view?
Yes, that would show up. I don't have an example of that, and I have not come across that myself, but I believe, now that I think about that one, I don't know for sure on that. I will write that one down and go look into it afterwards. That's a really good question.
Cool. Okay. We'll keep moving here.
Okay, on to the next example then. So this next example came up as week 4 in the database corruption challenge. And here's what we know. Basically, users started seeing an error message that looked like this. Attempting to fetch a logical page in a database failed. Okay, that doesn't sound good. And when we run CheckDB, we get a bunch of errors. And this one is so bad that CheckDB, after about 10 to 15 seconds, I usually stop it, because it just goes on and on and on with hundreds of thousands of rows of output of errors. But it basically is saying that there's a header that indicates that something's allocated to another object, and then there's some error messages as we go on about null values in a non-null field. So additional details, the full backup. Okay, the full backup we have is after the corruption occurred. And again, like a lot of the corruption issues that I come across that are the harder ones to deal with, there are no, they didn't have a good backup and restore schedule, so there's no backups prior to that at all. No earlier backups whatsoever. We have one backup of the point in time today that is when the corruption was encountered. So backups are out as a way to fix it. So what would I do first? Well, I'm going to jump in and see what I can find. And if my work makes things worse, no big deal. I've got a backup. I can just go back and use that. And I'm not going to do this in a production system. I'm going to do it on a development system And then once I work out the kinks, I'll do it on the production system. And then what can I do to determine what's corrupt? Well, I'm going to find what tables are bad and then start poking around and see what I can find when I query them. And then what can I do to recover missing data? Well, backups are out, so I'm going to have to actually somehow recover all of the data from the corrupt pages. All right, let's jump into the demo here. This one was week 4 in the database corruption challenge, and Patrick Flynn, who I believe is from New Zealand, provided a solution that I have based this part of the demo off of. It was one of the most spectacular solutions that I saw during the database corruption challenge, and I just want to share that with everyone. So what I'm going to do is start by restoring the corruption challenge 4 database. This one I have never demoed before, so this, or demoed in front of an audience before, so this is the first time demoing this one, but it's pretty darn cool. So let's take a look at it. We're going to check out the database and see what's corrupt. And I'm going to real quickly here hit the cancel button, because if I let that run, it spews out so much output that SQL Server Management Studio bogs down. But if we look here, it's complaining about some column that was created as not null, but it's null, and just pages and pages and pages of that for a total of a whole lot of rows there. 142,000 rows came out just in that quick time that I was able to have that running. So, but they all look pretty similar here. So what exactly does that mean? I'm not sure. So let's go take a look at things. So we're going to take a look at Corruption Challenge 4. We're going to use the database. Let's see what all is in here. So we're going to look at how many objects there are, and I know that's a good thing to check so that when we come back later, if we create or delete things, that we can get it back to the same count. And I'm going to look at what all the objects are in this database. So there's a total of 5 objects. There are a couple of indexes, a total of 3 indexes, and a total of 2 tables. Okay, so let's go, and I think that customers was referenced in the error message, so let's go take a look at what's in the customers table. Now in our previous example, we were able to get some good results out of what was in the customers table, but in this one, it failed and we can't pull anything out of that table. So sort of to make a long story short here on this part, there's a couple of triggers on here that prevent people from creating or deleting any tables. So I'm going to disable those triggers. I'm then going to create a customer copy table and go through and grab everything I can out of the non-clustered indexes like we did in the previous example, knowing that everyone can do that now based off the previous example. And then we'll take a look at what's there. And what I was able to recover was all of the IDs, all of the first names, and all of the last names, but we had no middle names at all that we were able to recover because there were no non-clustered indexes on it. Okay, well that means we have to get our hands dirty and dive in a little bit deeper. So what we're going to do, and the way this comes from, again, Patrick Flynn, who came up with this. We're going to create a table called Customer Copy 1 that we're going to eventually put things into as we go. We're going to create another couple tables here. Okay, so there's DBCC end, which gives you all of the pages in an index. And what we're going to do is create a table that we're going to fill up with all the output from that DBCC index output list. Temp table. And then we're going to create another temp table that's going to have all of the stuff that comes out of DBCC page for every one of those pages. That takes a while to run. And then we're going to create one called DBCC data, which is going to extract information from each one of those pages. And then it's going to start out here with running DBCC end on the clustered index and fill in that table. So there's 2,258 rows coming from the index. And it just says these are all the pages that make up the clustered index on that table. 2,258 rows. So then we're going to use DBCC page, and what the output from that looks like, here's an example of a bunch of different information using the with table results about all of the rows that are represented in that page. Now, even though the data is not in a good enough condition for SQL Server to query it, it's in a good enough condition for us to rip the data out from each slot column by column going through the output here. We're going to declare some variables. We're going to create a cursor. And then we're going to grab all of the pages out of that DBCC end temp table. And for each one of those, we're going to run DBCC page and dump the output from that into the DBCC data table. Okay, this takes a little while, and what it does is it goes through every single page in the database, and it grabs all of that information that DBCC page was able to spit out. All right, we'll let that's going to run for a minute, but then when it's done, what we're going to do is pull all of the data out of each of those rows that's inserted into that table and reconstruct the original table by ripping apart the data that was in the DBCC page output. And the way that that's going to happen is using this common table expression here, translate, which will go through and pull out some substring information for the slot, the length value, and the raw values. Okay, so that previous query finished. So we'll take a look at what's in DBCC data. There it is, and each one of these represents a different row in a page that has the information associated with the rows out of the table. However, the hex or the values that are shown here aren't entirely useful until we figure out how to rip them apart and decode them. So what translate does is it pulls out the slot and the position of every value in that table. It then puts it together into an ordered data to get it in the right order. We then so let me show you real quick what that does just by showing this part here. That grabs all of the pieces that we need to put together for the row numbers and where things go from each, keeping in mind that each slot represents a row in a table or in a page. Then we use that query to insert all of that into a table called temp customer data, bringing it all together based off of the page IDs and slots, lengths, values, and string values. That takes a moment to run, and it puts in 511,740 rows. We then take a look at what's in that table, and that looks like what we just looked at a moment ago, or close to it, with the output of all of the values with each of the pages, the slot, and the length of each data item we're working with. And then there's this hex string to var binary value that's needed to rip the data out of the hex representation and put it into a binary format that we can then reuse to insert the data back into the table. So I create that function. We'll clean it up later. We then run through this, and if I say select with this common table expression, converting each one of these, it turns them all into the positions for each row over here of where we find the offset of each element that's represented in the row. I know I'm going a little bit fast here, but you can look at the sample code later to work through it. And we're going to insert those substring values. So I'm just going to comment out the insert for a moment and look at what we pull back when we do the substrings based off of all those positions. And that looks like our original table with first name, middle initial, and last name. So we insert it into customer copy 1. Oops, there we go. So it's still running from before. So that takes a moment to put in those 510,000, if I remember correctly, rows. Or 511,000 rows. Okay, 511,740 inserted there. We can then look at how many's in there and confirm that, yes, that's the amount that we had in that original. So we're joining up them all on ID between the original copy and the second copy that we just did. And seeing that, yes, they do all match on IDs, so we didn't miss any rows. We then look at the count, and what this one is doing, we get 0 results. The count is showing, give me all of the rows that don't have a matching first name and last name, but the IDs do match, and there are none. Okay, so at this point, we're going to clean up our temp tables, and we know that the customer's copy 1 contains what we think is the non-corrupt complete set of data as it was ripped out of each of the pages. And we're going to go back and do some cleanup here. We need to put it back into the customers table, so we have to drop a foreign key constraint that we'll put back later. We need to use identity insert. We then truncate the table customers, which throws out all the corruption just by throwing away all the pages. And then we reinsert all of the data from our customer copy 1 table, turn identity insert off. That takes a minute to run. Oh, there's our 511,000 rows. We do a CheckDB on corruption challenge 4. All the corruption is gone. There's no errors reported. We put back some foreign keys, and we drop some things we created along the way, and we re-enable the triggers that were set in this database that prevented people from creating tables or dropping tables. Once that's done, we take a look at sysobjects, and we see we have the original 5 that we started with. And we select star from customers, and there's our entire list of 511,000 customers completely restored from a corrupt table where the corruption did not impact the data itself, but we had to use DBCC page to extract all of the data out of that table to get it back to where we were here. And this is something at this point, if this was a real database, you would then take this customer list and go compare it somewhere else to maybe something in a finance or accounting system to confirm that, yes, it looks like we do indeed have all the rows here. But what we do know is that we have all of the data from all of the pages that were represented in that clustered index. And the final thing we do is we run CheckDB one more time just to be safe, and all of the corruption is gone at that point. That right there, that solution was adapted from what was provided by Patrick Flynn, and it was a pretty darn cool way of ripping through all the data in all of the pages to rebuild the table from what was corrupt. And since we're short on time, I'm going to hold the questions till just after the summary here. So what we've covered is how to detect corruption, how to track it, things you should do before or removing corruption, or before fixing or removing corruption, how to go about removing it, and a couple of examples. Now, if you like those examples, there are 10 examples on my website, stevestedman.com, under the /corruption location, with multiple solutions for each of them. And keep in mind, when you get stuck, don't forget to ask for help, because that can be the difference between a fatal error and being able to recover all of your data. There's where more examples are. And you can find me at PASS Summit 2016, where I'm going to be doing a more expanded presentation on database corruption than what we've seen here today.
Very cool. Thank you. That was incredible. I've got a couple more questions. I've answered a few here. Just to wrap up, if you're using a non-clustered index that is filtered, is it possible to recover all the data from the corruption there that way? And it's probably one of those "it depends" answers.
Yeah. So it depends, and really what it depends on. So we know for a filtered non-clustered index that is only going to contain the rows that the filter is based off of. So it's going to be much smaller than a full non-clustered index on those same columns. But if the filtering happens to cover the same range as where the corruption is, you might be lucky and be able to pull the data back. Meaning if it's a table that's filtering on the last 30 days worth of data, or let's say a specific 30-day period worth of data, if the corruption was in those rows that were inserted in the last 30 days, yeah, you're going to be able to pull it back. If it was from 5 years ago, you're not going to be able to pull it back from that filtered index.
Cool. And one last question. What are some strategies for helping to keep the application alive when the database is corrupted? You know, basically keep it up while you're trying to repair.
Yeah, strategies to keep the database up while you're trying to repair. Well, first off, my strategy is always try the repair somewhere else first. Back up and restore to a test server or something. That way it's not going to impact that production system. But also take a look at where that corruption is. And it might be that that corruption is in a part of the table that isn't referenced very often. It might be 9-year-old data that nobody regularly queries other than like with a monthly report or something. Figure out where it is and figure out what the impact on the system is. Depending on how severe it is, you might not have any hope of keeping the application running. depending on where it's at, you might be lucky to let it run for a week while you figure out how to do the corruption on the side, or anywhere in between. But I would recommend, though, when you attempt to finally do the fix on the production system, that you turn off any applications and put the database in single user mode, because anything that anyone else is trying to do there could make your life very difficult.
Cool. One last question. What about restoring corrupt pages from a known good backup?
That's a really good question, and I think there's a demo I've done. One of the examples included something like that. You could, and this is sort of the 500 level database corruption type question there, where maybe 600 level if there's such a thing. You could, if you know the data page did not change and you had a backup, I would do the restore of the entire backup and have it on a test system and copy that single page from the corrupt or from the non-corrupt over to the corrupt, verifying that yes indeed it has the exact same slot count and yes indeed it has the exact same rows in it, and that it hasn't been shifted around through an index rebuild or something like that. But it is possible that you could, that could be done, and I've actually done that type of sort of copy and paste voodoo on data pages before to recover a database.
That's a good one. Cool.
Yeah. Don't try that ever in a production environment until you, ask for help before you ever do that one.
Excellent. Great advice. Great session. Thank you for presenting for us today. We'll get this recording up here really soon. And if you have any other questions, feel free to reach out to either us or Steve directly. And I know we'll all be happy to help.
Yep. Thanks for having me. I've had a good time.
Excellent. Thanks a lot, everybody.